Awesome.
Thank you all for coming. Just wanted to introduce myself a little bit and then hand this off to Yasher. The reason why my name is second is because I don't play a big part in Facebook scale, but Yasher does. I'll give you a little background about myself. Anyone have a Hotmail account still?
I do.
So I got hired at Hotmail after the Microsoft acquisition in 1999. And back then, email was a big thing. Back then, storing those emails and moving them from our mail servers into our backend storage servers was a big thing. We didn't have a good testing framework there. We just worked with vendors like EMC, HP, lots of companies to move that mail. Sometimes we found ourselves in interesting problems where we either saturated our network or saturated the IOPS that we could deliver, and we had huge issues. That was back then growing at scale, at big scale, and for us, back then in 1999 and 2000, a few hundred machines and a few thousand drives was big. Yasher's here to tell you what Facebook scale is now and how to get from being a small company to a really big one, something that I didn't actually see because I had left the Hotmail group some years ago. The thing that I learned at Hotmail and the reason why I am at Facebook is because I learned that there's something really cool about people that work on infrastructure, people who work on production issues, people who understand what's needed to make sure that when you release into production, that you've done everything you need to do to ensure its success, or if there's a problem, you work with many teams to resolve them. This is a really difficult area for a lot of people, but it's one that I'm very familiar with and one that I would like to share our experiences, and Yasha is going to do that because he has great experience at Facebook in having helped to build our infrastructure with the work that we do in our team. And our team is RTP, which is release to production. In release to production, what we're doing is trying to make sure that we release to production successfully. We do not want to have huge problems at scale, so we test as much as we can of the hardware and the systems before we deliver it to the data center. So I want to turn it over to Yasher, who's going to talk to you about all of that at Facebook.
Thanks. Stay. Thanks, Leo, for the introduction. And this talk will bounce ideas off and he'll come in. But I want to ask everyone in the room, how many people work on infrastructure or in infrastructure? Oh, and how many of you guys are in hardware specifically? Oh, cool. Okay. Awesome, awesome. Well, I'm a systems production engineer under Leo on the RTP team, and I've been on the team since late 2010 at Facebook, and so I've seen it kind of grow. And you know, we're here to tell the story. This is the first time we're actually giving this presentation outside of the company, but we want it to be a conversation between both of us. So please, if you have any questions in the middle, raise your hand, stop me, and I'll try to answer your question. And what else? Oh, one thing that I want to say about the RTP team is it's sort of the middle ground, the glue that brings site operations and hardware design and the service owners. And by service owners, I mean our application teams like timeline, photos, newsfeed, and so on, all together. And we sort of sit in the middle of and are a glue between all these teams. So before I go into the meat, what I wanted to talk a little bit about was my story and where I come from. I'll quickly go through this. So this is a picture of me as a baby. And I moved to Canada when I was 8 years old. I moved to a town called Waterloo in Canada. I don't know, anybody know where Waterloo is? Awesome, yeah. Huh? Oh yeah, it is in Brussels too, it's true. I went to elementary school in Waterloo and went to high school and then ended up staying at home and attending University of Waterloo. And for Canadians out there, it's known as the MIT of Canada, or at least that's what we like to claim it is. But there isn't that many universities in Canada. So, I attended a 5-year engineering program that's actually 3 terms per year, not 2 terms, and it's 4-month terms. So we end up what we do is we go to school for 4 months and then do 4 months of internship from the first year. So we keep swapping like that. And during my last year of 2 internships, I ended up getting a job at Facebook, and that's my photo of the first day I started at Facebook as an intern. And the funny thing is, when I started, I didn't even have a Facebook account, and I had no intention of. But what happened is my girlfriend at the time was pushing me to get a job at California because she wanted to move there and so on. And so I'm like, okay, fine, I'll interview. And then I ended up interviewing and coincidentally got the job. Um, uh, I ended up coming back for my second internship at Facebook where they gave me a full-time offer. And then when they gave me the full-time offer, I finished school and then decided to move to California. Uh, I ended up starting full-time at Facebook, but our relationship never lasted. So, but today I got married in 2012, and now I'm expecting a kid in September. So. And that's my picture today. So you can see Facebook's made me grow up with the facial hair. Um, okay, so what I wanted to start off with is first at a high level kind of go over Facebook's growth over a timeline. And you'll see this timeline. I'm going to use this timeline throughout the presentation, and you'll see why it's significant. But basically from 2010 to today, which is 2016, right? And looking at 2010, we were really had one service that we were supporting, which was the Facebook site with Messenger integrated into it with 600 million users, right? And as you can see, throughout time, the scale has really changed over time. And in 2016, which is today, we have 1.65 billion users on just Facebook, and we have all of these other products that we support, like WhatsApp, Instagram, Messenger, and then Live. How many of you guys know what Live is? Facebook Live. Yeah? Do you want to talk a little bit about Live?
Yeah, I just wanted to mention something that Live has gotten a lot of attention recently due to certain events, and there is a lot of internal discussion inside the company of the technology that was developed. There's a lot of pride in having technology that allows people to communicate at such high speed, but there's a lot of concern of how it's being used and whether it needs to be controlled or not.
Let me pause you for a second, Leo. So what Live is, for the people that don't know, is basically from your app, for your Facebook app, you're able to stream a live video of yourself to all millions of users, and what they're able to see is you live with very little latency, and comment and like, and you'll see all the comments and likes going across the screen. So keep going.
Yep. And so one of the things that we do is we have to support the hardware that enables these technologies to run. There's a lot of pride in what we do because what we're doing is on the back end, we're making sure that the hardware runs efficiently to be able to pull that video stream in and shoot it out to millions of people at the same time. This is a lot of work that we do in infrastructure to enable these tools, and there's a lot of pride in the company in having to deliver them to millions of users. But it's not without controversy. It's something that we feel it's our duty to do the best we can, the most efficient hardware we can to support all of these products.
Cool, and you might have seen Live on the news recently, but we won't go into details there. So here are some stats about Facebook. I'm going to give you a second to go through these stats and just look at them. To some of you, this might not mean much, but some of you that work in infrastructure, it might give you an idea of what we're working with today. One thing that is not covered here is actually our Facebook's pivot in 2012 to mobile. And if people that had Facebook knew that before 2012 we had a huge presence on web, and we didn't have a good infrastructure in mobile, and the company decided to pivot at that time, and today most of our users are on mobile. So that was one of the higher level pivots that the company had to make, and the decision that we had to make and move over. Another thing that I want to cover is 30 billion photos. I don't know, I mean, 30 billion photos. How many cat photos are those out of those 30 billion photos, right? And I work a lot with the storage seals closely, so that means a lot to me. And that kind of size leads to some really challenging work that I have to do on a day-to-day basis, but some really rewarding ones once you conquer those challenges. Do you want to give a perspective of Hotmail compared to this?
Yeah, well, it's a vast difference where maybe we were dealing with millions of spam emails back in the day. Back when I was working on the operations team to keep Hotmail running, our biggest problem was spam. Spam coming in at such a high rate that we couldn't keep up with it. And so we just would buy a bunch of servers just to keep loading the spam and then destroying it on the back end. This scale is way bigger, so much more impressive, and it's just amazing to see what the team has done.
Thanks. So now that we've gone through sort of Facebook's evolution and Facebook's growth, let's talk about Facebook's infrastructure evolution, right? And again, using the same timeline, I want to give you guys a view of how Facebook's infrastructure evolved. In 2010, we had a normal internet presence, right? We bought OEM hardware, and then we put them into released colo data centers, and that was it. And that worked for us at that time. You know, most people do this, but at some point we had to make a decision to change our destiny. As the company grew, we wanted to make sure that our costs didn't grow, our infrastructure costs didn't grow. So we needed to plateau that growth and make sure there's a gap in between those. And so that's when we decided to start investing in our own infrastructure. And we knew that this would be a long-term investment, right? So in 2011, we designed our first hardware compute node, and then our first data center in Prineville, Oregon. And then because the company's mission is to make the world more open and connected, well, why not open all these wins to the industry? And that's what open compute is. How many of you know what open compute is out there? Awesome, awesome, awesome. If you don't, you guys can go, it's opencompute.org, and it will give you, it's basically all of our infrastructure from data center to hardware to you know, some of the kernel that runs on top of it that's open source to everyone to use. And then there's two terms that I'll use, so I'll define some of the terms that I'll use throughout the presentation. One is OEM, which is original equipment manufacturer. That's like our HP and Dells. And then there's ODM, which is original design manufacturers, which is sort of the model that we started using after 2010, which is like your WeWin, your Quanta, your Foxconn, you know, how your phones are made. So we engage with those individuals and those companies and provide specifications and come up with the designs, and they help us manufacture the hardware or infrastructure that we need. And then, as you see, as we scaled and our needs expanded in 2013, we invested in our own hardware storage design and opened our first data center in Luleå, which is in Sweden, north of Sweden. And there was many reasons for that, and which I'll cover later. And then today, we're building 2 new data centers, which is one is in Fort Worth, and another one is Ireland. And then we're redefining our network fabric topology. As you can see, you know, in 2011, what we were doing was simple, you know, designing a compute node, and today it's a lot more complex. Again, some stats for you guys to look at. I'll give you a second to go over those.
And also, one of the things that causes a lot of our storage bloat is that we have to replicate a lot of our data to make sure that we have reliability. We want to make sure that even though that cat photo is not precious to me, it might be precious to you, and we don't want to lose any of the data that you've ever uploaded. So we have multiple copies in different data centers, and we try to ensure the reliability that way, but it just costs us.
And I wanted to just cover another point. We say many exabytes of warehouse. I'm not sure if everyone's familiar what a warehouse for Facebook is, but a warehouse for Facebook is basically somewhere that we store all your interactions with Facebook, like the likes and you know, all of the comments that you've done, your relationships with people, and so on. And we were able to run analytics and determine, for example, your news feed algorithm and what we want to show you or not. So that's warehouse. And then Everstore, or what we call media storage, is where all your photos and videos are stored. This is a picture of all of our data centers currently around the world. As you can see, we're starting to increase our presence in Europe and hopefully in Asia. The reasons for that is not only latency, but also disaster recovery, right? If something happens to the US or something goes out, that's a transatlantic line, we still have a presence somewhere else. Any questions right now? So that's interesting. So one thing that's not covered on this.
Repeat the question. Just
Oh, sorry. What the question was is, it's interesting that there's a few, so few data centers, and what's the expansion plan? Right now, as I said before, the expansion plan is just the 2 data centers that we're building in Ireland and in Fort Worth, which are the 2 yellow items. But what's not covered in this is our POPs, right? And POPs are huge, and there's a lot of POP presence. And what POP means is basically these co-located, where multiple, service providers live, and it's usually owned by the service providers. And what we do is they're hubs for us to be able to cache data and so on. So does that make sense? Yeah, these are our owned data centers. So I mean, these are very megawatts of power usage. And I'm going to show you some slides as we go through. The next 3 slides, there's a bunch of pictures. And what I'm trying to show here is sort of how we have to think of the entire stack when we design our infrastructure. From the application that runs on the servers down to the cooling of each individual server and the way we control power. So you want to talk a little bit about this?
Yeah, one of the things that we do to make sure people are very sensitive and very well aware of the issues in maintaining a data center is that we have a program called Data Center Immersion. That means that we go for a week to one of the data centers and we are given classes and training, and then we're actually sent out to work on some of the servers so that we know what it's like. The reason why that's so important for our team is that everything we release to production is going to hit these data centers at massive, massive scale. So the immersion is a true immersion. We get trained and we go walk the racks. What you see here in these big buildings are cut into 4 parts. Each of those is called a data hall. And inside the data center, it's quite huge. There are literally hundreds and hundreds and hundreds of racks inside there. And there's just one little area for people to work in, and a little area for maintaining parts. So when you walk inside, it doesn't actually look quite as nice as this. This is all lit up. A real data center has no lights on until you start walking. It detects that someone's walking around, and the light follows you. What's really interesting is that it's this dark hallway where you got your little crash cart, and you're walking through the hallway, and the light's following you. It's a hard life to work in those hallways because it feels so lonely. Where all you hear is this constant hum of these machines. So the people who are dedicated to that work, I mean, they are quite impressive of how meticulous they are at taking care of those machines.
And one thing I wanted to mention is here, you can tell, I don't know if you can see the contained sort of aisle, that's the hot air aisle. And so traditionally, right, in normal data centers, what you'll have is just racks in the middle of open space, and you'll cool the whole space. When we're designing our data centers, what we did is we designed the hardware and the infrastructure in mind. So all the hardware is the hot air aisle is contained. So the hot air gets pushed from the servers to the back, and then rises up through the top to this slide back. This slide to this area where the fans push the hot air out, and then in front of the racks, where it's the cold aisle, that's where fans push cool air from the outside in. And we don't use traditional AC cooling. What we do is those fans have these sprinkles of water in front of them, so the air gets pushed through the water and pushed down to cool it.
And just for a scale, on the picture with the fans, those things are about 6 to 8 feet tall. They're very, very big.
And this is just a slide that shows how the rack and this is the storage, this is the switch on your left, and the data center, how it all comes together, right? And let's keep going. Now, let's talk a little bit about Facebook's hardware evolution, which is where we live mostly, right? We live from the kernel space down, so kernel, hardware, OS, and so on. So, um, again, using the same timeline, in 2011, that's when we noticed that a huge increase in users. And Webbies, front-end Webbies, which is our front-end servers that serve the traffic, were high in demand. And that's when we decided, okay, this is where we need to innovate first and design our own hardware. And we designed our first compute server called Freedom, and our rack and power, which was a triplet. In 2012, we ended up just iterating on the same Freedom design called Windmill, which was, instead of having one compute node, it was two P servers in one U chassis. In 2013, our storage needs started increasing with the number of photos people were storing and so on warehouse data. And so we ended up designing our first storage JBOD, which was called Nox. And also we redesigned our rack and power, which we call Open Rack V1. Instead of each server having a power supply, what we ended up doing is the rack has its own power supplies with a bus bar in the back, and the servers plug into that bus bar. And skipping to 2015, as we started disaggregating, basically disaggregating compute and storage, our rack-to-rack traffic started increasing. That's when we realized, okay, the industry isn't innovating fast enough. So we started designing our first network switch, which was called Wedge. And then also our first archival storage, which is Blu-ray, which is basically a big, you want to talk about Blu-ray a little bit?
Just as much.
Yeah, it's just a robot basically that takes Blu-ray discs and takes them out, burns data, and puts them back in. It's for data that's cold, what we call cold. And then in 2016, we're investing in GPUs for machine learning. We designed our own cluster switch, which is the big switch, because we redesigned our network fabric. And then also we're investing a lot in SSDs, because the industry is moving towards there, and our applications are becoming more latency sensitive. So.
Yeah, one other thing to say about the Honey Badger system. That system, the storage server there in the middle on 2015, called Honey Badger. The specifications for that, you can find it online. It's all written up, including the story behind it that shows Honey Badger is really that Knox storage JBOD being married to a CPU board, a microserver that we call the Panther Plus board. By marrying these two, we're able to take a JBOD from being a simple JBOD to actually being a storage server on its own. And basically, one of the things that the team does is try to take project work from other groups, merge them, and make a new project out of it. And Honey Badger was one of the first times they did that.
And that story is key, because we don't want to just design for the sake of designing, right? We want to, if there's solutions out there, we want to use those. It has to make sense for our business, right? Which is to connect everyone around the world. So, let's go. Do you want to? This is.
Yeah. So we've been talking. Well, Yash has been explaining a lot about the infrastructure hardware introductions as we've been going from CPUs to storage servers to network. We want to bring this all back to the reason why we're doing this is because we're so big, because we've gotten so big that we have to keep pace with what our applications and our marketing people are telling us, that we are going to have an increased demand. And so, again, we're working at a large scale, and to achieve large scale, it's quite an effort to go through iterations and all the testing that you have to do, and testing automation, and that's where Yashu will continue the discussion of how we did this.
Before we go there, a couple of reasons of why we do this, right? First, we talked about this, optimizing end-to-end stack from application to cooling the DC, right? We design for our customers. Who are our customers? They're all the application owners. That's, like I mentioned before, timeline, messenger, photos, warehouse, and so on, right? And an example to think about is when we look at an application, we think about, okay, what is the storage to compute ratio that an application like your newsfeed need, right? And how that question will affect our capacity planning, how many servers of compute and storage we can put into a data hall, because storage servers pull usually a lot more air than compute servers. And so CFM, which is like cubic feet per meter of airflow, is a big concern. So we can, that's a good example to think about of how your application needs affect really the cooling and everything in a data center. So we always want to have the whole stack in mind. Next is, a lot of times we find that the industry isn't innovating quickly enough for us, right, to meet our needs. So what we have to do is we push the boundary by working with our partners in the industry, right? A great example of this is Yosemite. I don't know if anybody has heard about this design, but traditionally what the industry had been doing was designing these 2P servers that were really powerful but really bulky, right? Made it hard to scale. So what we ended up doing in 2016 is designing a sort of modular design so that we could scale on demand. And what this is, instead of having a big bulky 2P server that takes up a 1U space in a rack, we ended up designing sort of a board that has 4 cards that plug into it that have an SoC, a system on chip, that plug into this board that share a network card. And 3 of those fit into a 1U chassis. So now you've gone essentially 4x from number of CPUs that you had traditionally. And that allows us to scale quickly based on the demand of the application. Operational efficiency. This is a big one for our team because this is what we do on a day-to-day basis. This is what we work on. It's hard to quantify operational efficiency, but it has a huge impact on efficiency and cost of our operations. One rule of thumb that we try to follow to keep it simple at Facebook, keep designs simple, make sure that it meets our need, and reduce the number of configurations that we have. So if we don't have to create a new SKU of hardware, then we won't. We'll utilize what we already have. Power optimization, I mean, this is simple, like make sure you have the most efficient power to the rack, and this is one of the reasons we use 277 volts to the rack, and we have a bus bar that I talked about earlier. Commoditization of hardware. This is a little bit complex area to talk about, but basically all of our designs, we open source them, right? And one benefit of that has for us is it makes it commodity hardware. What does commodity hardware allow us to do? It helps us drive volume. It has, we can have multiple sources. It helps with pricing, and then also obviously reliability, right? If multiple people are using the same hard drive as us, that's a good thing. Most likely things will be caught before we catch it in our infrastructure. So. And lastly, standardization, right? We work, we innovate, we design. Sorry, I couldn't hear you. Storage, yeah, hard drives. I mean, yes. If you look at our Open Compute website, you'll see that all of our storage servers are also open sourced. Yes. And currently, Knox is actually sold by our ODMs to other companies. No, I'm talking about just at the hardware level, right? So that's the design that I talked about earlier. I can answer your question in the Q&A section. Thank you. And then standardization. So yeah, we innovate in the industry, but we wanted to make sure that it's standard. We don't want to have a one-off solution, right? So a great example of this is the way hard drives report their statistics, right? Which I don't know if you guys know, but it's smart, right? But every hard drive vendor currently reports it differently, and that can be a huge hassle when you're trying to integrate a new drive into production. So we work with the hard drive vendors and with different companies to make sure we standardize it so everyone reports in the same way. It makes it less complex for everyone. I want to stop. Actually, before I stop there, obviously this isn't invented by Facebook. This is just our story. The only difference is Facebook is open about it. And we know that our investment in designing our infrastructure is a long term, which I talked about already, and it's really driven by our needs and what our customers need, and making sure that we're always running the most efficient infrastructure. Um, and I guess one question that we consistently ask ourselves is, are we using the most efficient infrastructure for our applications, for our needs, right? And did you want to make a comment about?
Yeah, one of the things that is really impressive about the team and how they work is when I relate this back to, again, my experience working at Hotmail. As some of you might know, but this kind of may date me, um, Hotmail was a Unix shop before Microsoft acquired it. And as such, once the acquisition happened, one of the things that we had to figure out is how do we convert everything we did in Hotmail to run on Windows or Windows sanctioned hardware. It was a massive undertaking, and one of the things that taught me that when you're introducing a new system at scale, if you change too many variables, big variables, you're gonna run into a lot of trouble. Your schedule's gonna blow out by at least 3 times what you thought it was. That 1-year project is 3. And it's gonna burn down teams. Changing the operating system and the hardware at the same time was crazy. Something that you can only do when you have a really deep pocket funding you. Something that Facebook doesn't do because we wanna make sure that this is efficient.
Thanks, Leo. I want to stop here before I go on and see if anyone has any questions or things that they want cleared up.
In your data centers, what's the hardware attrition rate like, and what actually happens when some hardware goes?
So, and that's a really good question, actually. Right now, where things are changing, but anywhere between 3 to 5 years, I would say, is traditionally what we use hardware for in our data centers, and I'll cover that. It's actually the last section called how we do is decomming the servers. So we'll go into the details of that. Any other questions? So the question is, for data replication, what is it for photos and videos and so on? It actually depends on what sort of block layer you're running on, and we're transitioning. I mean, traditionally, everybody knows we used to use our own version of Hadoop, and for warehouse, and Haystack for our sort of media storage. That's changing over time, and we're redesigning our block layer. I mean, replications could be 3x. Now we're moving to Reed Solomon, and I couldn't answer that question specifically, but yeah, it depends on what block layer you're running on.
And also the question is interesting because when we dig in and when the question gets asked, how much are we replicating, sometimes we surprise ourselves because we may have different layers working on storage. There's a high level client, there's a middle layer, and they may each have replication, and in the end, you may find surprises that you're wasting space, which is why we're redoing those layers.
Great.
Was there a question in the back?
How do you prepare for scale before you have it? That's a really good question, actually. And that's one, actually, I didn't cover it earlier, but one thing I wanted to say is one overarching statement that I wanted to make early on is you don't. In most cases, you don't, and you'll see that in the rest of the presentation. But what you can do is have a team that's a go-getter attitude and really opts into the challenge when they don't know what's going to happen, and learns from those challenges and make sure they improve as you move forward. And that's one thing that I would say when we're thinking about our team, the characteristics of our team that our teams have. Any other comments?
No, good.
So what I was going to cover here is some bumps in the road. And this is basically to your question of how do you prepare for skill when you don't have it. This is some of our learning and challenges and what we learned from and how it defined our DNA today in infrastructure. So that same you've seen the slide, and our first design was Freedom, which was our first compute server. And what the sort of our mindset going into designing Freedom was, let's strip everything that we didn't need that was in the typical OEM server, which was like the HPs and Dells. Let's strip everything that we don't need, and we'll make it simple, not power hungry, and so on, right? And what happened? So one of our learnings from this was, first thing, we had thermal challenges with this. So we made cluster planning really hard because it pulled a lot of air, and we couldn't build the density that we wanted in our rows, in the racks, in the clusters. And also we decided at the time, we thought it was smart to remove the BMC. Who knows what the BMC is? Baseboard Management Controller, right? And what the BMC is a management sort of chipset on the board that if your main CPU goes down, you're able to access your server and manage it and turn it off, turn it on. It connects to your power, it connects to your sensors, and so on. And so we learned from that because that caused huge operational inefficiencies, where basically once the server went down, you had to send a tech, and the tech had to go power cycle the server instead of us being able to do it remotely. And when you have thousands of servers, that's basically a tech's job the whole day to go and power cycle servers. So we learned from that. In our next design, which was the same basic server, but instead of having one two-piece server, we had two sleds in one use chassis, we implemented a software BMC. So basically, it was an abstraction. We used the same main CPU, but used sort of a software BMC on top of that. That was a huge learning for us because we realized that it didn't give us the reliability and the separation that we thought it would give us. And so in a lot of times when your server went down, your software BMC went down also, which, well, great, okay. And then another thing is on the windmill design, we turned on turbo, and it ended up pushing our racks are designed to 12.5 kilowatts limits, and there's a breaker that would trip. We turned on turbo thinking, oh, that would be great. Our applications will, benefit from that. And then it tripped a bunch of racks. So we learned from that. And I'll talk about a system that we developed to manage that. This one, I'll just talk about memory bandwidth. In our Winterfell design, which was 3 sleds, we ended up sort of taking memory bandwidth optimization and memory capacity, and we made a supply chain decision. So instead of using, for example, 4 gig DIMMs, we ended up using 2 8 gig DIMMs, and thinking, oh, that should work fine. And realized that we hadn't done enough application testing, and our application, it didn't meet the memory bandwidth didn't meet the needs of our application. So that was a big learning, and we learned that we have to do aggressive application testing and performance measurements before we ship a server. I'll talk a little bit about this area because this basically affected a year and a half of my life and sleep. And this was HDD failures. In 2013, when we rolled out our first Knox platform, we were excited. It was our first JBOD, and we ended up using the hard drive that was at the forefront in the industry, the biggest capacity. We ended up going with one vendor, and we rolled out thousands of racks of this. And basically, in 6 months' time, our application owners came back to us and said, hey, I think I'm failing a lot of hard drives in my tier. And this was mainly warehouse at the time, because they had the biggest deployment. And we're like, no, it's just a software glitch. Don't worry about it. And at that time, we didn't have any monitoring tools. We actually we didn't know what our failure rates were, except what was being swapped in. And we're like, we left it for another 2 months, and finally, I remember there was one of the PE's production engineers came to me. He's like, hey, you have to really look at this. Like, we're failing a lot of hard drives. And that's when we started looking at this, and we were panicking, and we were pulling data and putting in Excel sheets and forming diagrams on the spot to prove that, yeah, our hard drives are failing. And once we proved that, yeah, they were failing at a really high rate, we had to think of, first of all, with the vendor to figure out what the root cause was, then figure out a short-term mitigation plan and a long-term mitigation plan. Short-term meant, how do I keep the service from today from losing data? Because we have such high failure rates. And long-term is, what are we going to do with all these hard drives that we're deploying to our infrastructure? And I'll tell you, today we're still swapping some of those drives. So
Yeah, just one little bit of that. I mentioned before that I went to the data center as part of the immersion to understand what they do, and one of the exercises to get me to understand what happens if a hard drive has to be replaced is that the tech has to be very, very careful. All the parts are checked, they're scanned to make sure that they're properly disposed of, and that means that they have to be carefully moved from where they are in a server out to a holding pod, and once we collect enough drives in a holding pod, we very carefully move those drives over to the crushers. Those crushers are just a machine that just tears the drive apart. We have to verify that all the data is crushed down to the point where we just have a pile of metal at the end, and then a big metal box is moved out to some other recycling system. It is so intense to crush 100 drives in a day that I don't know how the guys do it, but they do it, and they have to check every part.
yeah, yeah. I wish I had a picture of a pile of hard drives that were crushed, but I don't. Um, uh,
Either the fires from the magnets when they get crushed, the fires.
I've never seen that actually.
Yeah.
That's pretty cool.
Crush them yourself.
Yeah, he's crushed some. That's cool. So what do we? I mean, this was a big. Are you okay? This was a big learning for us, and things that we implemented and that I'll talk about as into the presentation is dual sourcing, right? Never go with one vendor, so that if one vendor has a bad drive or something or bad batch, it doesn't affect your whole infrastructure. Oh, sorry, go ahead. We ended up swapping all of them. So this is thousands of drives. Huh? Which it was one type of drive with a specific manufacturer, yes. Yeah. I can't go into the details of that, but we came up with a settlement with them. So yeah, dual sourcing, right? Never go with one source. And the HDD industry is now basically two big guys, which is WD and Seagate. So that it makes it harder, but that's one thing. And the other thing is monitoring. This actually was the reason we have really matured in the last 3 years in the way we monitor our dashboards and anomaly detection, and I'll talk about that as we go. And then vendor engagement, making sure we give our hardware to the vendors so that they can use their expertise to test that their components in our hardware and make sure it doesn't fail. And lastly, quickly to cover this, in our ORV1 rack design, we never had PSU monitoring. And during a lightning storm, it killed a bunch of our power supplies. We didn't notice the power supplies were dead until some racks started shutting down. Then we had to send techs out to check all of the LEDs on the power supplies and then swap the bad ones. So that was an area that we learned and fixed it on our ORV2, Open Rack V2 design. Yeah.
Going back to the hard disk, do you actually see the commodity disk that we can get or go on you can buy? Western Digital, for example, has 10 different kinds of disks. They call them, I don't know,
Yeah.
they color code them.
Yeah.
Do you actually see a difference, and do you have a specific variety that you use
Yeah.
for your purposes?
Yeah. For our main purposes, so Everstore and Warehouse, we actually use their enterprise drives, right? Which is SAS 7200 RPM type of drives. Yeah, I'm sorry. I know that's a no, but that's what we're used to, and we're looking into building our infrastructure to make sure that we can use anything, but we're not there yet, basically.
Yeah, it's been a hot topic for us to see if we can get onto SATA, but it does take a lot of effort. It takes a lot of coordination at massive scale, but we are looking into it.
But that's a good question, right? Because we started using SaaS because we were small and we wanted to use the best thing that was out there, and all of our tooling and our infrastructure is built around that. Now, yes, we do use SATA for our cold storage stuff, but moving our main services like warehouse and Everstore to SATA will take some effort. And once the decision is right to make, we'll make that decision.
Once you make it, is it 2 years out?
Yeah, that's true. Yeah, exactly. And what else? So again, one thing that I wanted to overarching thing that I wanted to say about this is at the beginning we made rookie mistakes, right? Because our scale was small, those rookie mistakes we're able to control them. But those rookie mistakes, if we make them today at the scale that we're running at, they were detrimental to our infrastructure. So we have to keep learning and implementing that learning into our infrastructure. So I'm gonna dive into. Do you have any comments?
No, I just want to make sure we're checking the time.
Time? Oh yeah, I don't have that much time. So quickly, going through sort of what hardware lifecycle looks at Facebook, right? This is the phase that some of you might be familiar with, starting with hack, to design, to build, deploy, sustain, and then decom at the end of the day. And I'll cover each of these areas and sort of the systems and tools that we built around all these areas. So hack, what is a hack, right? This is a good picture of what a hack looks like. Jay Park, which was one of our directors, this is our first data center power design, and he sort of brainstormed an idea on a napkin, and now it's basically this is what's implemented in our infrastructure. Yeah. And so it's really a brainstorm idea to solve a problem in our infrastructure, right? That's what a hack phase does, and what you have to do in a hack phase is you might get a bunch of components off the shelf to prove your hack, engage with your stakeholders, prove that it makes sense for the business. Why are you doing it? Does it solve a big problem for our infrastructure? Get approval from all the big stakeholders, and does it fit into our overall mission or not, right? And then once you have that idea and you've proved the performance and TCO and so on, then you go into business review. And in business review, basically all the stakeholders sit down and get approval. Okay, I think this is a problem that we're solving and this is good. Let's go into NPI, which is new product integration. And once it's an NPI, that basically all the teams work to make sure that product goes into production.
Now, one thing that I've noticed being fairly new to the company is that this effort of getting through a review, going from hack into a sanction plan of record, it's quite intense because there's quite a few stakeholders here. There are suppliers, there's our team, there's a hardware designers, there's a software guys. There's the people who run the business want to make sure that we're making the right decision long term, because it's going to take us many, many months from this phase to actually having a full rack at full production. It's going to take us at least a year, it may be closer to a year and a half. And so it's a massive investment we're going to make.
So once we're in, we got the approval, we'll go into design. And what is design? You finalize the specification, you work with your ODMs, which are the Quanta, Foxconn, WeWin, or whoever, to come up with schematics, board layouts, and then you manufacture your first EVT samples, which is your evaluation stage of the product, right? And this is the typical design phase that you go through. You kick off the project, our team will identify the new technology, what's missing in our testing, build the proper test plans, and then take it through the different exit gates, which are EVT, DVT, and PVT. I'll go through what those are, and then go into pilot. A pilot is a small deployment of that new product into our data centers, and basically our services will run on them and make sure there's no issues, and then we'll go into production. And as I said, that could be anywhere between 3 to 5 years. And this is what the exit gates are. I don't know, some of you might be familiar. EVT is engineering validation test, DVT is design validation test, and PVT is production validation test. And in those areas, I'll cover what is covered. This is a really busy slide, but basically I just want to take your attention to 2 areas. One is systems and tests. In EVT, you have 10 to 12 servers in your lab, and you're just basically doing SI measurements and making sure the hardware works, right? Then you move into DVT. DVT is basically a couple racks in your data centers, and there we're running stress testing, serviceability, app performance, making sure all the tooling is built around automating this rack from beginning to end of its life, and so on. And PVT, you're basically in PVT, everything from beginning to end should flow smoothly, right? My team should be hands off in PVT, and if we did our job right, you should power on the server, and everything should flow normally. And then you're in prod. So as I go through this timeline, you'll see these gray boxes that are hanging off each phase. And this is basically systems, tools that we've implemented based on our learning. And one is our testing framework, right? At the beginning, when we started in 2010, it was just a bunch of individuals, like 6 or 7, that were doing the hardware design, that were testing the hardware, and then giving the thumbs up, okay, you're good, go into prod, right? And it worked then. But as we grew and our projects became more complex, the numbers of servers that we had grew, and the number of applications we were serving grew, we realized that we needed a testing framework, right? And that's basically, this is a quick snapshot of our testing framework. It monitors all of the projects. It's a portal for our partners, teams, stakeholders to come and get a high-level view of what we're testing, why we're testing it, why does it matter to them, and see what the progress is, and they'll see what the failures are, what the passes are, and so on. Next, well, as we scaled, we also realized that the number of projects, the number of configurations we had to test, we couldn't do it any longer by hand. So we had to automate our testing. So we built an automation testing framework. This basically framework allows us to cover multiple configurations. Testing lead can build different test suites and kick them off on multiple configurations. And there's a portal that basically monitors the progress and tells you what's failed, what's passed, what else? What we can use this for is in the future, if we ever do firmware releases, kernel releases, or anything on that same hardware, we can use the same regression test suite to just run it and automatically run it without any user intervention, and make sure that that new firmware or kernel or whatever is okay for production.
And at the lower level, is that all a bunch of Python code?
Yes, it is. It's really Python. Yeah. And with some database stuff that helps with the portal. Now comes the build. This is the part that the manufacturing quality team, we're involved in it, but the manufacturing quality team is very actively involved. This is in 2011 to 2015. What we used to do is the ODMs made the components, the motherboard, the chassis, assemble it together, and then shipped it to our integrators, which were in region, for example, in the continent of North America. And then they would put it into racks, do some testing, and then ship it to all of our data centers. In 2016, that's because we scaled and we needed to be more flexible, have quick turnarounds. What we were able to do is, instead of shipping fully made servers, we ship components now to the integrator, right? And the integrator has the flexibility to build as many as they need on demand because the parts are there. And they'll do the testing and then ship it from there. And basically from after the integrator to when it goes to the data center, there's very little intervention from us. The rack comes in, it has to be powered on and basically serves traffic. One thing that I think this is key for our team, what we noticed is that hardware testing is just not enough anymore, right? We can use our vendors to do hardware testing, but where we add a lot of value is making sure that this piece of hardware works in our infrastructure. And our infrastructure is getting complex and more complex over time, right? And so, yeah, the hardware might work, but once you put it in our infrastructure, the tooling might not work around it, it might not meet our needs, and so on. So that's when we came up with NPI testing suite, right? It's the same, it uses the same, did you want to add something here?
No, okay.
Oh, it's good? Okay. Sorry, I didn't know what that he wanted to add. So it basically uses the same portal, but it's a test suite that tests provisioning. It tests failure mechanism. So basically, we will fail a hard drive and make sure our tools detect that failed hard drive and it goes through the proper process, right? Make sure our decoms work. Sorry?
What does NPI stand for?
A new product introduction, right? So it's testing a piece of new hardware in our infrastructure, right? And
In the bigger picture, we don't ship, like if we develop a new CPU server or storage server, we don't ship a CPU or storage server into the data center. What we do is we put it into a rack with a special top of rack switch, and it has certain requirements that it has to meet. It has to be powered up, which we call energizing, and from that, it has to automatically configure the top of rack switch and configure all the servers in the rack. If anything goes wrong in there, our automation is broken. That means that when it hits the data center, it won't work. The data center guys are there to unload a massive truck full of racks and bring those trucks in efficiently into the data center, energize them all at once, and let them all automatically come up. If they don't automatically come up, then they're going to call us, they're going to call the hardware designers, they're going to call the production support people, and the data center guys are going to scramble to try to get it all back online. We can't have them doing that, which is why we developed this NPI testing suite to make sure we cover those cases before we ship those racks.
thanks, Leo. We're running a little bit out of time, so I'm going to scramble. So this deployment, this is exactly what he was talking about. Once you deploy it, we should not touch it. The rack comes in, gets powered on. The top of rack gets switch gets provisioned. You detect all the assets. They all get provisioned. We enable monitoring rules and test the hardware, make sure that there's no failures, there's no hard drive failures, and so on. Then we enable the service and pass on the racks to production. And so this should be all automated, and that's why we have built that NPI testing suite. Yes, go ahead. Sorry.
How do you determine what apps should run on what server?
That comes way earlier on when we're designing the hardware and the whole infrastructure, right? We design the hardware to meet our top user applications, for example, Warehouse and Everstore, and see if that same hardware design fits to the smaller. So we design for their biggest users, basically.
So during provisioning, how do you know how to allocate capacity?
So that's more of a longer planning discussion about capacity management that we do with another capacity team we work with. And there's tools that we use to decide how to name the servers so that they go to a certain group of people.
Yeah. It's basically, there's a team that works, and we can talk about after the details. And sustaining, this is a big, big area for us. This is where the hardware spends the most of its time, and we spend most of the time there. And there's a lot of learning that goes into this area. I'll have to cover it quickly, but it's the monitoring and sustaining I'm going to talk a little bit about for 5 minutes. We all know hardware will eventually fail, right? And what we have to do is make sure that that failure doesn't affect our infrastructure, has the least amount of effect on our services that are running on that hardware. So we implement 4 elements into our sustaining. First is monitoring. Make sure we're monitoring our hardware, we're monitoring trends, and so on. Then, and you can see we didn't monitor before, right? With the HDD failures, I had to pull Excel sheets and so on to build some graphs. Then we build alarms so that we can detect any anomalies in trends, and we have to remediate those. So remediation is a little bit complex. Remediation can be things like day-to-day remediations with known failures, or it can be a little more complex than that, which is like when you have the hard drive failures, what are you going to do? What is the short-term remediation? What's the long-term remediation? And then design feedback. We have to consistently be improving our designs to make sure that we don't make the same mistakes. And so first, monitoring. This is a quick snapshot of some of the dashboards that we have to monitor all of our hardware. And these cover many servers, many services. Our first one that I'm going to show you is the hardware component dashboard, which basically lists all of the main hardware components that we monitor. And then it has AFR, which is annual failure rate, on the left, and then on the right is basically your daily AFR. And the dotted red line is the threshold. If we pass over that threshold, we know that something's wrong, or that's our rough threshold for us to make sure that we're under. And then on the right, you have filters by tier, cluster, data center, and so on. So that was more of a high-level dashboard, and something that is more in-depth is our SAS dashboard, or our hard drive dashboard for our SAS drives. And this is the front page of the SAS dashboard. It has failure rate, which has 7-day AFR, 30-day AFR, and annual AFR. Then it has error types categorized by color and number of errors, failures, sorry. And then the total counts. And different tabs in this dashboard will go more in depth. For example, correlate temperature of our hard drives to failures, correlate number of uncorrectable errors, and so on. And then same filters as we talked about earlier. Next is alarm. This is complex, and we're really learning this here in this area. A lot of our tools are new. It's easy to detect a sudden spike. What's harder is to detect slow trends or cohorts that are not behaving similar as the rest of the infrastructure. And so this is where we're trying to use some machine learning and so on, and implement different solutions to detect anomalies and be able to take action on them right away. So this is remediation. I talked about this is a complex area. I'll give you two quick examples. One is out-of-band. In 2014, we realized that our out-of-band health, which is basically out-of-band is the connection that you have to your base management controller, which is the sort of the sideband that you talk to your server in case your main line is cut out or your server is dead, to power cycle the server, to pull some sensors and so on. And this has a huge impact on our service owners, because if they want to do firmware upgrades, they want to do provisioning, it won't work if your out-of-band isn't working. So what happened is we were able to identify in 2014 that we had bad out-of-band health. We identified the reasons, and we started tackling each of those. And we were able to bring down our out-of-band health significantly, or failures significantly. Second one is, I already talked about hard drives. In 2013 or 2014, we started seeing huge hard drive failures. We were able to work with the vendor, identify what needed to be done. We swapped, we did firmware upgrades, and so on to bring down our hard drive failures.
And this is work that continues today, that as we talk to the hard drive vendors that are asking us that they've got new drives they want us to purchase, we have to make sure what happened in the past doesn't happen again. So we test the drives much more thoroughly than we ever tested them before to keep that AFR coming down.
Yeah. With all the things I talked about, like dual sourcing and canarying, we'll do canarying for long term. Go ahead, sorry.
Do you think, observe that if you run the rack 2 degrees higher, you get some number of errors? And do you do some kind of optimization there?
Great question. That actually leads to my next slide, design feedback. So this is a dashboard for hard drive slot temperatures, and you knew what I was going to talk about. And this is actually our Knox chassis, and you can see the front is the green, and the back slots are the red, and you can see that the 3 back slots run much hotter than the front slots because the air gets heated up, and as it moves to the back, the hard drives in the back run hotter. And then we have another dashboard that says, well, what are our hard drive swaps? And what we noticed is that certain drives that were more susceptible to temperature fail at a higher rate at a higher temperature. And you can see the back slots in this diagram are failing at a higher rate than the front slots.
So to get at in a bit more detail, some drives are susceptible. Some drives have bad tolerance, a bad margin. And we have to test for that to try to find those margins and try not to introduce those into the field.
Yeah, exactly. Or basically work with our hardware design to make sure that we're cooling the chassis evenly throughout. And so basically the point of sustaining, the goal of sustaining is to detect issues early on, find root cause faster, which will lead to better infrastructure reliability and an operational efficiency, right? If we can automate all of these detections and without user intervention, it makes us a lot more efficient. Last couple of slides. Am I okay? No? Okay. Let's run through this. I don't need to cover these areas.
That's automation, yeah.
That's automation. This slide is just showing our different heartbeats, hardware changes, firmware changes, kernel changes at its own pace. And if we take one snapshot at one time, we can see multiple things changing at the same time. And that leads to a huge increase in our number of configurations, right? And that can become a nightmare to deal with. So we have to make sure that we stop this increase in the number of configurations. And that leads to a lot of the tools that we have implemented. And lastly, decom. And this is what someone was asking about, and this is what happens. Once the system is at the end of its life, we'll have to drain and migrate the cluster. This actually, although it seems simple, it can be an area that allows us to scale quickly or not. And if we can innovate in this area, it really allows us to scale faster. Because draining and migrating a cluster can take months. And if we can do that faster, then we're able to grow our infrastructure, right? And when we have to migrate, decom a cluster, we have to identify new data center, build new infrastructure there, put new power, put new racks there, move all of the information, all the data to the new cluster, and then take the old cluster and upgrade it, tear it down, build new racks, build new hardware, build new network infrastructure, and so on. So this can take months. But this is an area we're trying to learn from as we grow, and because it becomes a bigger of a pain point when you have to decom thousands of racks. And that was it. That's it.